evening, depending on where you are. And welcome to the Satmoc training session for the summer 2025. Satmoc stands for Satellite Meteorology, Climatology, and Oceanography Committee that under the umbrella of the American Meteorological Society. Satmoc committee for the summer training session has been organized the training sessions in the past 4 years now. This year, our theme is satellites and fires. So in total, this season, summer season, we'll have 4 training sessions. Each training session will last for about 4 hours. The topics including an introduction to environmental satellite capabilities. That's today's first session. The second session will be the day after tomorrow. That will be pre-fire phase of wildfires. Then the third session will be on June 24th, will be active fire phase of wildland fires. And the last session is a post-fire phase of wildland fires. So you can see that we kind of give you an introduction of the satellite data and then go on to talk about the pre-phase, active phase, and then post-fire, post-phase of the fires. And the fires have been very important topic, especially during the summertime. So it's very timely, and I hope you enjoy the training here. So before we get started, I'd like to thank the Satmoc working group for the virtual training. Believe it or not, this working group has been working together since the early January. Almost every 2 weeks that we have a meeting organized by Gary McWilliams, and then those are the members that you can see that from universities, from the federal agencies, and we try to put a good training materials for you. So I just want to acknowledge those that who have contributed to this meetings. Certainly, Megan Christensen is the host, and she's also from University of Iowa, and we also like to thank her for make the Zoom link available for everybody. So our today's speaker will be Chris Smith. He is a GOES-R satellite liaison for the National Weather Service, Weather Prediction Center and Ocean Prediction Center. He provides training on new satellite data products to meteorologists and delivers feedback to developers to maximize the capability of satellites for weather forecasting. Chris received both a bachelor and master degree in atmospheric and oceanic sciences from University of Maryland. And today he's going to give us an introduction of environmental satellite capabilities. So with that, I think that this is another kind of our advertisement is that there will be a NOAA satellite hackathon in October. So what you learn there might be able to enable you to participate that hackathon, and you can scan the QR code there to participate. Again, please welcome our speaker, Chris Smith. Chris, the floor is yours. Thank you.
Thank you for the introduction, and thanks everyone for being here today. I'll pull up my presentation here and get started. All right, and if that looks good, I can go ahead and get started here.
Yeah, looks good.
All right, thank you. So everyone, welcome to AMS Satmoc 2025 short course on satellites and fires. Today I'll be giving a general overview of an introduction of environmental satellite capabilities. There will be a section on vegetation monitoring and fire conditions. So my name is Christopher Smith. I'm the GOES-R satellite liaison, as the introduction said, for the National Weather Service here in the U.S. for the Weather and Ocean Prediction Centers in College Park, Maryland. I work out the Cooperative Institute for Satellite Earth System Studies at the University of Maryland. Wanted to give a little more introduction about my role here. at the National Weather Service infusing satellite products from GEO and LEO, so geostationary and low Earth orbit satellites, into operations, serving as a research to operations or operations to research connection. So getting new capabilities to forecasters, but also delivering feedback to satellite product developers to actually make sure their products will be useful in operations. I also help develop outlets for testing new products and provide training on how to use those products. So an outline of today's sessions, there will be 4 different sections, and I think with the amount of time allotted, we should have plenty of time after each section for some question and answer, and I also built some time in there. There will also be a break after the second and third sections. And we'll start with an overview of the satellite architecture for section 1 before diving more into the capabilities from GEO and LEO themselves. Then we'll get into the wildland fire and vegetation monitoring with GEO and LEO and some satellite resources. So once you leave here today, you should have a bunch of web-based resources to view satellite imagery and products on your own. So we'll get started here with part 1, an overview of the satellite architecture. And starting off with environmental satellite capabilities, satellites provide sustained observations to monitor the environment compared to the ground-based observations, but best used in tandem to really understand what's going on with the environment. Numerical weather prediction and weather models rely heavily on data assimilation from satellites, again, because of the amount of aerial coverage and frequency they can gather information on the atmosphere compared to just ground-based observations. So starting with geosatellites, I keep using that acronym for geostationary Earth orbit satellites. Those are your fixed orbit with routine monitoring over the same location. So if you think of the GOES satellites here in the Western Hemisphere of the United States and South America, Himawari, for example, from Japan, or Meteosat from Europe, help form a georing or almost global coverage of geostationary satellite imagery. Compared with LEO or low Earth orbit satellites, these have higher temporal frequency, again, viewing every 5 or 10 minutes for certain locations, but they have lower spatial resolution, viewing from an extended orbit. An example here on the right is the georing, what we're hoping to move towards with geostationary satellites across the world. This is proxy-vis imagery, which can help view low clouds at night using a linear regression of the visible and infrared bands from these geostationary satellites. So I do have links on the bottom of each animation here, so you hopefully can access in the future. So low Earth orbit satellites, unlike GEO, they have lower temporal frequency because they are orbiting around the globe from the poles, but they have higher spatial resolution. These come in the form of JPSS from the United States, MEDOP satellite series from Europe, among others. This is helpful, especially at the poles where the geostationary limb view gets quite extreme. And these microwave and infrared sounders are heavily used in data assimilation for numerical weather prediction because they can penetrate cloud cover and get vertical temperature and moisture information of the atmosphere. Here's an example of what an AMS-2 pass will look like. This is from a tool we have here at the National Weather Service where we can actually plot out where a polar orbiter satellite will go and at what time to plan for observations. So GEO and LEO satellites in general do have some similar instruments, but also some differences. So GEO and LEO satellites will both have imagers. So for example, on the GOES satellite here in the United States is the Advanced Baseline Imager, or the ABI. GEO satellites also tend to have lightning mappers. We have that on the GOES satellites. EUMETSAT also just launched a lightning imager on Meteosat 3rd generation, so viewing some lightning from space. And then low Earth orbit satellites, in addition to imagers, often have microwave and infrared sounders. Again, that's getting the vertical temperature and moisture profiles of the atmosphere, scatterometers to measure ocean surface winds, and synthetic aperture radar is a new capability that's becoming widespread to measure ocean surface winds, see ice cover and extent with high spatial resolution. And I'll get into some of these capabilities in section 2. So getting into geoimagers a little bit, this is like the GOES ABI imager. Routinely observe in the visible, near infrared, and infrared ranges for wavelengths of bands, and spatial resolution varies roughly from 0.5 kilometer for the visible channel to 2 kilometers for the infrared. Some of these spatial resolutions are improving with new satellite launches like Meteosat 3rd generation, which now has a 1 kilometer infrared viewing. Temporal frequency can vary from 1 minute to the mesoscale to 10 minutes for the full disk. So on this image on the right here from GOES East, the full disk is that global view that you can see here on the right. In the United States, we have a CONUS sector that looks over most of the United States mainland here with 5-minute temporal frequency, and then mesoscales or smaller areas where usually there's impactful weather to observe with 1-minute imagery. So full disk 10, CONUS 5, mesoscale 1-minute sector imagery. LEO imagers, again, have the similar types of wavelengths, similar instruments, visible, near infrared, and infrared, but they have higher spatial resolution. So instead of 2 kilometer infrared, you might have it at 750 meters. So spatial resolution from those bands generally varies from 375 to 750 meters. And temporal frequency, at least at the lower latitudes, is about every 12 hours. You'll get a pass twice a day from a LEO imager, but there is a constellation to get you imagery more frequent than that. And if you're closer to the poles, you will have more frequent passes than at lower latitudes. Other geo instruments, I introduced lightning mappers. So GOES has a geostationary lightning mapper, GLM, and Meteosat 3rd generation now has a lightning imager. And instruments detect lightning through changes in brightness compared to a background image. A spatial resolution is about 8 to 10 kilometers. Again, this allows views of lightning around the globe in addition to the ground-based networks that are already there. And products like the flash extent density that I'll introduce provide the number of flashes over a grid cell in a given amount of time. Analyzing trends in the lightning can help you detect convective initiation or maintenance and even severe thunderstorms. For low Earth orbit instruments, microwave and hyperspectral sounders. So microwave instruments such as the Advanced Technology Microwave Sounder, or ATMS, aboard JPSS, for example, or a US-based LEO constellation right now, penetrate cloud cover to gather vertical temperature and moisture information, along with hyperspectral sounders like the Cross-Track Infrared Sounder, or CRIS instrument on JPSS. Again, together, those have a huge impact on data assimilation into numerical weather prediction because of this vertical temperature and moisture information that can be provided into the weather models. Other LEO instruments, altimeters and scatterometers, definitely here at the National Weather Service Ocean Prediction Center. These are important instruments for understanding marine weather. Scatterometers and altimeters use radar to infer surface wind speed and direction and wave height from backscatter on the ocean surface. Seeing wind speed and wave heights from these satellites is really important due to the lack of observations over the oceans. No U.S. polar orbiters currently have a scatterometer on board, but we do partner with METOP satellites, for example, like I said, with METOP B and C having the ASCAT instrument you may be familiar with scatterometry. And synthetic aperture radar, this newer capability that is becoming widespread that I introduced, simulates a large antenna by combining a sequence of acquisitions. and that simulation allows for high-resolution imagery. Sentinel-1, RadarSat-2, and RCM are a couple of examples of SAR satellites. Sentinel-1 from Europe, RadarSat-2 and RCM from Canada. And these normalized radar cross-sections provide views of ice cover. You can easily detect ice edge and icebergs, and you can use an algorithm to infer wind speed from this normalized radar cross-section as well. So that ends part one with a short introduction of GEO and LEO, and I can see if there are any questions as I'm leading this solo. So I'll stop sharing my screen for a second and see if we have anything into chat. Alrighty. And Megan did put into the chat that links to slides, Zoom recordings, and all survey links will be posted on the CSUCR website. And yes, direct all presentation questions to the Q&A on your toolbar, or it might be under More, and surveys will be sent out after. Is CONUS only available for the USA or North America is one question in the chat. And yes, the CONUS sector from GOES is only for the continental United States, so that 5-minute imagery from GOES is for the CONUS sector only. If you're outside of the United States viewing GOES imagery from GOES East or GOES West, you can view the 10-minute full disk imagery. There are some instances where mesosectors will be moved outside of the CONUS, and that's the 1-minute imagery for impactful weather. Another person had asked from LEO orbiting satellites, can we get soil moisture and rainfall data? And I actually will be getting into some of that in further sections, but you can have microwave-based rainfall rate and accumulation data from LEO orbiting satellites, and soil moisture is a capability I'm definitely going to get into with vegetation monitoring as an important input for fire weather. So you can look forward to that in section 3. And I'm typing short answers in the Q&A to follow up. I'll give it one more minute before we move on to section 2, which will be GEO and LEO capabilities. Sorry, I was muted there. Can GEO satellites detect all types of lightning, cloud to ground, cloud to cloud? What's the accuracy of detection versus ground networks? If you come to the another section with Joseph Patton, if you register for the short course, he's our GLM expert. So he will know all types of lightning detection, or if he's online, perhaps he can answer. I'm not sure about it detecting every type of lightning. I know the accuracy is pretty good there. The detection rate, I think, is above 90%, so it should be pretty accurate. But again, using in tandem with those ground-based networks and other ground-based observations is really where you're going to maximize your capabilities with these satellites. Alrighty, I'll give it one more minute and then we can move on to section 2. And someone did put in the chat that they can't see the chat by Megan with links, but we can copy and paste it back in there for you. Thank you, Megan. Alrighty, and we will get started with section 2 now, diving into LEO and GEO capabilities. So diving into satellite imagery a bit more, this is from those imagers like ABI on GOES or VIIRS on the JPSS satellites. Satellite imagery can be viewed by individual band, or bands can be combined into create red, green, blue, or RGB composites to detect certain types of weather phenomena.
RGB. We're still seeing the PowerPoint presentation mode.
Let me reshare. Thank you. I think this should solve the issue. Is that better?
Yes, great.
Okay, thanks. So I'll dive into RGBs a bit more, but I wanted to start with some of the ABI bands, for example, and the Advanced Baseline Imager, and this is similar among other geostationary satellites like Meteosat and Himawari. But ABI channels, we have 16 channels. Some of the most popular, at least in the weather community, that you may be familiar with are the visible band 2, the clean infrared band 13, your lower, mid, and upper level water vapor bands 8, 9, and 10, and the shortwave infrared band 7, which I'll get into later for its importance for fire detection. VIIRS has a couple of additional bands. Most popular bands, again, generally they have the same wavelengths as ABI with some additional. One that you may be familiar with that the ABI does not have is the day-night band, which is an input to the near constant contrast, where you can see city lights and things like that at night. That's also going to be a band I introduce for fire monitoring later in this presentation. So here's a chart of the ABI bands on the right, some of the same information I introduced in the last slide, but you can actually see all 16 bands there. And the type of band, the nickname, red, blue, red, veggie band, and the spatial resolution. So they are band 2, the visible band at 0.64 microns has the best spatial resolution at 0.5 kilometer, while most of the other bands have spatial resolution around 2 kilometers, including the popular infrared clean long wave window band 13. So those are the individual bands. Now getting into RGBs, I'm going to be introducing some that are used by forecasters the most at the U.S. National Weather Service. Now there are several other RGBs for different types of applications. I will also be introducing some additional RGBs for fire weather detection in section 3. But just know this is just an example of some of the capabilities, but all of the RGBs online should have quick guides like I'm going to show in the next slides. So a couple of the RGBs that are used here at the U.S. National Weather Service are the Day Cloud Phase Distinction RGB, the Air Mass RGB, the Nighttime Microphysics RGB, and the Viz IR Sandwich RGB. So starting with the Day Cloud Phase Distinction RGB, this is a main application for convection with the ability to see different phases of clouds. So here are what the quick guides look like. All of these, or most, are provided by CIRA. So in addition to what I'm presenting here, there's a lot more RGB examples on that website. But all these quick guides will have examples of what to look for in the RGB combination. Again, they're combining different bands to really pick out some weather phenomena. So in the Day Cloud Phase Distinction RGB here on the right, you can see when convection is maturing. So in color 1 here with the blue, you have low water clouds. And when there's green introduced, there's some ice in the clouds. So it's invigorating, and 4 there, thick, high-level clouds with ice particles, more intense convection. So really useful for depicting thunderstorms, convective initiation, and things like that. Another aspect that is neat about this RGB is you can see the bare ground here is blue with normal vegetation, but you can actually see snow cover here with the ice reflection box 3 here, so you can see snow cover. This is another great aspect about the day cloud phase distinction RGB. The air mass RGB, this is a popular one around the globe to track intensifying extratropical cyclones. Again, this is a really important product at the Ocean Prediction Center where we can see rapid intensification, again, with a lack of observations. Due to being able to see water vapor difference bands, you can see the amount of ozone being detected from stratospheric intrusions of air that have high levels of potential vorticity that can lead to this rapid cyclogenesis. So those colors are going to be red there in 1. And then you can also see just air masses in general. The dark greens are tropical air masses. You have cold air masses in the purple there as well. And again, this is through using those water vapor bands to see different air masses through water vapor. So red is going to be dry upper levels, for example, where there's a lot of stratospheric intrusion and ozone to lead to that cyclogenesis. The nighttime microphysics RGB, again, also a popular RGB around the globe. This allows you to see convection at night, but also phenomena like fog that you can't really pick out in just infrared imagery alone. So the main application is for tracking fogs and low clouds here in the U.S. National Weather Service. Some imagery viewers that I'll show in the satellite resources in section 4 allow you to see a really nice transition from that day cloud phase distinction RGB I introduced and the nighttime microphysics RGB as well. So here's an example on the right. Fog is going to have this dull aqua to gray color like in box 1. Not to be confused with box 3 here where there's more of a bright green aspect. That's just a low water cloud, but not necessarily fog like box 1. You can also see really intense convection like box 10 here with a red, yellow, or noisy color from very cold cloud tops in the infrared channel. The Viz IR sandwich RGB, and I have a nice animation here of Hurricane Beryl from last year. This is a combination of the visible veggie band 3, which has really nice contrast as the ocean acts like a black body in band 3, with the clean infrared window band 13 on top. So you get the cloud texture information from the visible band 3 with the temperature information from band 13. So definitely a popular RGB at the Weather Service and for phenomena like tropical cyclones. So you can see here the visible IR sandwich RGB, and in our workstations, we're able to overlay other data sets like the geostationary lightning mapper total optical energy to see what intensity the lightning is from satellite-based detection. For example, this Category 5 hurricane, which was the earliest in the U.S. Atlantic Basin last year, had a lot of lightning there in the northeast eyewall. So very intense hurricane here shown on the right last July. So there are also other types of imagery being produced. That CRIS sounder that I introduced in section 1 where JPSS polar satellites are getting temperature and moisture information from the atmosphere. There's actually being synthetic imagery produced at NOAA NESDIS. And these are allowing RGBs to be viewed around the poles. So where those geostationary satellites can't really reach up to, for example, northern Alaska, this is filling a gap of service there. There's air mass RGB, the SO2 RGB, and water vapor bands being produced by this synthetic imagery. And a lot of these experimental products and things in development can be found on CR Slider, which I'll be giving an overview on section 4. But you can see the air mass RGB here on the right from last year in May. You can actually see a storm force low there in the Bering Sea with some of that red signature indicating stratospheric intrusions of high potential vorticity air leading to an intense extratropical cyclone. GLM, flash extent density. This is the most popular geostationary lightning mapping product. With high flash extent density, meaning more lightning and stronger storms in general. Again, this is really important for looking at convective initiation, maintenance, and even the decay of convection. So this is a cold front from early March this year. So early spring here, and we can see some intense storms. For example, tracking from eastern Texas into Louisiana, you see really bright flash extent density outputs, meaning more intense thunderstorms, and a well-defined cold front here, pushing through the central U.S. But this is a lightning-based detection from space, and a lot of great information provided from that. Derived motion winds. These are produced by combining a sequence of images available for GOES and most recently from LEO imagery as well. And these help identify jet maximas and wind shear. So these derived motion wind vectors will be produced at different layers from the atmosphere. For example, on the right here, you have upper level derived motion winds from 250 to 400 millibars. In cyan, you have 400 to 700 millibar winds, and in yellow, lower level winds for pressures greater than 700 millibars. These quick guides, again, are available online, but seeing the different wind speeds at different levels can help predict what type of weather, for example, if there's efficient shear for thunderstorms, and these are available from geosatellites as well. So getting more into scatterometers and how they work, they are found on non-US LEO satellites right now. Some examples are MEDOT-B and C ASCAT instruments from EUMETSAT, and the OSCAT-3 OSCAT scatterometer from the Indian Space Agency. And these are satellite-based microwave radars that measure return signal to produce wind speed. Short wavelengths of scatterometers can cause rain contamination issues. So for example, ASCAT is a C-band scatterometer, while OSCAT is a Ku-band scatterometer. And Ku-band scatterometers have shorter wavelengths, making them more susceptible to contamination from backscatter from the ocean surface. So that can be a double-edged sword. These Ku bands can detect higher wind speeds, but they're more sensitive to getting erroneous values as well. So it's important for scatterometers to be in tune with ambiguities in direction and large changes in wind speed that can signal rain contamination. So an example here on the right from a COMET module on satellite applications for high latitude maritime wind hazards shows a MEDOT-B and C ASCAT pass from September 2022. This is the extratropical transition of Typhoon Merbok that had really large impacts in western Alaska. You can see in the northwest quadrant of this extratropical cyclone here, a really big increase of wind speed up to, it looks like about 50 knots or so. And that is where around ASCAT does contaminate or saturate about 50 knots. And you can see this elevated area. This is when it's really important to look at some microwave rainfall rate data. That was a question I know we just had in the Q&A. If polar orbiting satellites can measure rainfall, they do have microwave-based rainfall rate, again, penetrating the cloud cover. And you can see there was actually heavy rain right there in the same area. And that can help us signal that there is some rain contamination. You can also see, if you look really closely after this presentation, if you can access, there's some northwest winds crossing over these northeast winds. Again, some ambiguities in wind direction that can help let you know that there is rain contamination in this scatterometry imagery. Synthetic aperture radar. This is from the normalized radar cross-section. Again, simulating that large antenna, you can get really high resolution imagery. So this is an example on the left. You can see the ice edge quite well compared to other microwave imagery from LEO satellites where it would be much coarser resolution. This gets down to about 500 meters or less. 500 meter winds as well on the right. This is for a tropical cyclone last July heading toward Texas in the United States, and SAR imagery allows you to see a lot of the banding features there. You can see intense convection here out in front with an outer band, possibly getting wind speeds up to about 40 knots or so, and then the large easterly quadrant where there's stronger winds up to 50 or 60 knots. Altimeters, these are also found on a lot of non-US low Earth orbit satellites. Some that we access here, the National Weather Service, are Jason 3, Sentinel 3 and 6, 3A and B and Sentinel 6A, Cryosat 2, Altica, and SWAT. So these provide some along track wave observations. This is for Hurricane Raphael last November in the Atlantic Basin just southwest of Florida. And you can see significant wave heights up to about 23 feet. So these really allow observations, again, where there aren't as many over the oceans to see where hazards are for marine navigation. These satellite-based microwave radars measure return signal to produce wave height. So there's an example there on the right. I always like to overlay the altimeters, if you can, with different types of imagery so you can see kind of a validation. Those higher wave heights make sense as you're closer to an intense system there. Microwave sounders, these are available, for example, in the US JPSS satellites, among other low Earth orbit satellites, measuring microwave emission from the atmosphere. On the right here, we have 89 gigahertz RGB, and you can see the red colors here indicate a lot of ice. So in the cloud covers, that can mean cold cloud tops and intense convection. This is almost like an atmospheric river tracking toward southern Alaska and western Canada. But you can also see the ice and snow cover there in Canada and Alaska as well. And the brightness temperature information can detect ice and convective clouds, really useful for tropical cyclone structure as well, and seeing where the most intense banding is and the inner core of tropical cyclones. These microwave sounders allow input to precipitable water products. Those are definitely important in the National Weather Service. Algorithms in NOAA, like their Microwave Integrated Retrieval System, or MIRS for LEO satellites, allow precipitable water output. We can see actually precipitable water at different layers, like the advected layer precipitable water. Shown here on the right, you have the surface to 850 millibar, 850 to 700, 700 to 500, and 500 to 300 millibar layers. Really useful for seeing the source and length of a moisture plume heading toward an area and how that varies at different layers. So this shown here on the right, for example, was an atmospheric river last month in the eastern United States. We see precipitable waters heading here toward Maryland, DC, and Virginia, up toward 1.5 inches, which is pretty high for early to mid-May here in the mid-Atlantic. And if I zoomed out farther, you would see this source and moisture plume heading to the eastern U.S. was actually coming all the way from the Western Caribbean and the Eastern Pacific. Can also combine the advected layer precipitable water imagery with winds from global models like the GFS to produce layered vapor transport. A lot of model fields have integrated vapor transport, so this allows a direct one-to-one comparison of models and satellite imagery, see if the models are detecting the moisture plume correctly. So these are some of the precipitable water products that are really dependent on microwave sounders from LEO satellites. Infrared sounders from low Earth orbit satellites allow input to NuCaps. Again, those instruments, the infrared and microwave sounders, provide vertical temperature and moisture information of the atmosphere. And the NOAA Unique Combined Atmospheric Processing System, or NuCAPS, provides instability information. Can even look at SCU-T soundings of the atmosphere from the information that this gathers. So here's an example. In South America, you can see these different colored dots, at least, and where we view in our operational workstations. Something to note here is that NuCAPS does not have viable retrievals where there's really thick cloud cover from the infrared sounder. So that's those red dots there. The yellow have some contamination, and green in clear skies. You can have really good information to see the stability in the atmosphere prior to a convective event. So clicking on one of those dots, you can actually see some SKU-T information here in profiles. So this is a NuCAPS profile showing soundings, over a wide geographic area where you don't have to wait for a radiosonde or balloon launch. And you can see most unstable layer CAPE there is 1578 joules per kilogram, mixed layer CAPE 1413 joules per kilogram. Just an example of some of the parameters that we can see from NuCAPS. So I'm going to stop sharing and just a knowledge check here that you can put into the chat. What are the benefits of GEO satellites and LEO satellites, and how are they different? If you could put that in the chat, I'm just going to exit out of full screen, but keep sharing this window and you should be able to answer those. While I wait, I will answer a question in the chat. What is the difference between water vapor channels, top, bottom, and middle? So those goes ABI channels. There's a lower, mid, and upper level water vapor channel, and with their spectral response functions, the absorption of water vapor at different channels, you can see how much moisture is there at different layers of the atmosphere. So the upper level water vapor, again, is going to see water vapor detection at higher levels of the atmosphere compared to the others. So it's really the spectral response function, but you can see where the moisture is residing in the atmosphere. That can be important for weather forecasting. I do see some answers coming in the meeting chat there, which is great. And if you have any Q&As, you can also put those in the Q&A tab if you have questions, and I can provide answers while we're waiting for those to provide some responses. And I'll allow about 1 more minute here as we still have a lot of responses coming in, seeing a lot of great responses here. All right, and I'll provide a summary of some of the great responses that we're seeing in the chat. Everyone seems to be tracking right as expected. LEO penetrating cloud cover, definitely a great benefit of those microwave sounders from low Earth orbit you can't get from geo satellites. LEO has higher spatial resolution, where geo has higher temporal frequency, and geo having being farther out can capture a larger area at once. That's true. Yes, everything seems to be going well. And that's the knowledge check for here. So now I'll get into some of the Q&A and keep them coming into there before we move onto a break before section 3. So we have plenty of time. I can answer some of these questions. Do sounders have passive sensors only? And sorry, I was trying to see if I could answer live there, but sounders are passive microwave, that's correct, but some of the other capabilities like synthetic aperture radar that I introduced are active microwave sensors, and that's getting the really high spatial resolution. So there are some capabilities like that on the low Earth orbit satellites that provide some active microwave capabilities. Some conversation there about having a helpful way to communicate our science and connect to WhatsApp group or something possible. I would say stay tuned, but always appreciate having the interaction here in this committee to share science. Can LEO and GEO differentiate cloud and smoke layers? That I will get into in the next section. Actually, there's some great RGBs that are produced to see smoke versus clouds and fire detection. So I would say stay tuned for that for section 3. And I see a question there. Are LEOs the same as polar orbits? So yes, sorry if I'm interchangeable there, but low Earth orbit and polar orbit satellites are going to be the same. So I can reference them as polar orbiting satellites going forward to be more clear. But yes, they are the same. So sorry for the confusion there. Which can detect fire with more accuracy? Detecting fire with more accuracy, again, depends. GOES will give you the more timely observation of fire detection, those geostationary satellites, while the polar orbiting satellites can give you the higher spatial resolution for fire detection. So if you're looking for a really defined perimeter, you're going to want one of those polar orbiting satellite passes. But for fast detection, those GOES satellites. And there are some tools and dashboards now that will rely on both geostationary and low Earth orbit satellites. So for fire detection, they might rely on GOES, but once you get a polar orbiting satellite, provide additional information on the fire. And I will get into some examples in the next section. Does the CRIS software live on satellites? So the CRIS is actually an instrument on our JPSS satellites in the United States, those polar orbiting satellites. That infrared sounder is on those satellites, and I will show you in section 4 where to access some of the imagery for those polar orbiters, so you will have global imagery from those polar orbiting satellites that I can show you. The VIIRS day-night band product, I would again say wait for section 3, since that one I alluded to is important for fire detection. I will get into that one in the next section. And which is better for air quality satellite missions. I didn't really get into in this presentation, but there are some out there like Tempo that exists to measure air quality parameters. So I personally am not sure the polar or geostationary satellites, which one is better for air quality. But I know there are satellite examples out there like Tempo that I'll put into the answer for you. Great. I'm just typing some answers here. You can keep the questions coming as we do have some time. I do see a mention there in the Q&A if there's an updated link to the agenda. The link provided was for the 2024 agenda. So if there's an updated link for the 2025 agenda, Gary or Megan, that would be great. Alrighty, and can I talk about the flood mapping from LEO if time permits? So yes, those low Earth orbit satellites from VIIRS, for example, those polar orbiting satellites on JPSS, using that imagery, you can actually do flood mapping. I can, when we get into some of the resources in section 4, show where some of those flood mapping products are located. Synthetic aperture radar, again, that really high resolution, 500-meter resolution, also does flood mapping, so you can see when there's river or stream flooding. So LEO does provide that capability, and I'll try and show some examples in the resources because I don't have them directly in the slides. There was a question about when Google's FireSat satellite constellation will be available for use. I actually learned about this myself last week, so I know that is a new capability there. I'm not sure when it will be available. I know that NOAA, the National Oceanic and Atmospheric Administration here in the U.S., is aware of that satellite constellation, but I'm not sure when that'll be available or if there's any restrictions on that data. But I can try and look into that after this. And Megan put the updated link into the chat. We are ahead of schedule here, as the next section is section 3, Geo and LEO use in wildland fire and vegetation monitoring. I did put a 10-minute break in now, so we can go ahead and take a 10-minute break unless there are any other questions, and return around 10:10 or so. Elevation or warmer areas and things like that. This is an algorithm that's operational at NOAA, so it should be reliable. It's always good, again, if you have the availability of a nearby site to cross-check for validation. That's always a good practice, but they should be able to be used on their own. And limitations on orography or warm areas, etc. I don't have any off the top of my head. I do believe there's a quick guide, like those RGB quick guides that I showed for new caps, so I can try and look into that at the next break as well for you. In the chat, Gary also said that the suggestion of creating a WhatsApp group, he'll look into that with the organizing committee and provide info before the end of our short course next week. So if you're attending all 4 sections, you should have some more information on that coming your way. So I'll share my screen and we'll get started with section 3, which will be geo and LEO use in wildland fire and vegetation monitoring. All right, and are you able to see the full screen or just the PowerPoint?
Just the PowerPoint.
Okay. Not again. Okay, I will.
Zoom is finicky.
Yeah. There we go. I think once I do this, you should be good.
Looks good.
Okay. So now we'll be getting into use in wildland fire and vegetation monitoring. So we have an overview of GEO and LEO architecture, LEO as in polar orbiting satellites, and some of the capabilities and instruments on each of those. So now we'll see how this really ties into the short course on satellites and fire. All right. So I want to expand on a band I introduced from the GOES satellite, the 3.9 micron shortwave infrared window band. Again, this can be found on other geostationary satellites as well. But with this band, you actually get to see the surface emission radiation. That's where the spectral response function maximizes, so you can see actual surface temperature. Here's the raw output from showing a burn scar on June 18th, 2024. This is from the Reduso fire in New Mexico here in the United States. And you can see the bright output where there's more surface emission radiation in the shortwave infrared band. With fires, this is also called the fire detection band, this band 7 here, and it has 2 kilometer spatial resolution. So the VIIRS day-night band, I'll show an example later, but you can actually see the glow from wildfires at night. That's another great band from the polar orbiting satellites. So expanding on RGBs, I introduced some that were just popular in general at the U.S. National Weather Service. Now there are a lot of RGBs actually cater toward fire and hotspot smoke detection. Again, similar to those issues brought up in the chat and Q&A earlier for distinguishing fire and smoke versus cloud cover. So some of these RGBs that are used include the day, land, cloud, fire RGB, the fire temperature RGB, the microphysics RGB, geocolor imagery, and the ash RGB. Now, there are other RGBs that can be used for fire detection as well, but these are the top 5 that I chose to introduce for section 3. So looking at that same burn scar area in Reduso, New Mexico, the day, land, cloud, fire RGB, actually you can see that in more of a natural color scheme to the human eye. This utilizes the visible band 2, the veggie band 3, and cloud particle size band. So fires emit radiation at band 6, which is used in the red component. This is a burn scar here. So you see the lack of vegetation from the veggie band with that dark brown area, and aids fire and burn scar detection. So I'll be introducing things about burn scars as well in this section because post-fire, those areas are very susceptible to debris flows and flash flooding. So this is the GOES East Dayland Cloudfire RGB from June 18th, 2024. And again, I'll show you where some of these RGBs are located on the Sierra slider. Fire temperature RGB, a very popular RGB for actually looking at fire hotspots. I'm using the snow ice band, particle size, and shortwave infrared band. Again, band 7 or the fire band can detect surface initiation and fires at lower temperatures. The brightness temperature saturates for band 7 around 500 Kelvin. And fires that are even hotter than that actually show a response in the particle size band 6 and snow ice band 5. So the red component in this RGB is used for band 7 to show hot spots, and even hotter fires show up as yellow or white colors. So here's the quick guide on the right. Again, all of these can be found online. Box 1 there is the fire hotspot. So at night with the background, you'll actually have a black background. You can see the hotspot there in box 1. During daytime, 1 and 2 can indicate some fire hotspots, and burn scars look like box 5, more of a maroon color, not as hot as those bright red fire hotspots. But definitely a very useful RGB for showing fire hotspots in real time. So this fire temperature RGB, also used to depict the intensity or temperature of the fire. I will get into the next generation fire system being produced here at NOAA, but the microphysics RGB is one that has been developed recently using band 7. Again, you'll notice the theme there with the shortwave infrared band 7 as an input to a lot of these fire products. The clean long wave window band 13 and the dirty long wave infrared band 15. So this has a daytime and nighttime signature and fire and pyrocumulus detection, especially during the day. So these RGB quick guides there on the right, they usually show the recipe for how these red, green, and blue components are produced, which is really nice. You can see daytime fire detection here, for example, when the shortwave infrared has a big thermal input, you'll see a lot of blue there. And then at night, you'll see more of a green background and the red colors as well. So you can see in daytime, these dark blues indicate daytime fire detection. At night, those bright red colors indicate some of the fire detection as well. And pyrocumulus, you can see that ash is actually absorbed by band 15. So you can see some of the pyrocumulus clouds there as well. The ash RGB can be used for smoke as well. I know there was a question about that, utilizing the cloud top band, band 11, clean long wave infrared band 13, the long wave infrared band 14, and the dirty long wave infrared band 15. Detecting ash plumes, this only uses IR channels, so it can be used 24/7, day and night. And here on the quick guide on the right, you can see the different types of detection. So box 1 there, ash is going to be pure red to magenta. And then this also helps with sulfur dioxide for volcanoes and things like that. Okay, and I do have a video here. This is GeoFire. So this is a variation of GeoColor. GeoColor uses an algorithm to view the Earth with kind of a natural color as you would expect the human eye to see from space. And when we overlay that fire temperature RGB that I introduced earlier, you can actually see what a fire may look like from space with the human eye. So this is from a fire in July of 2024. There are blogs from the Satellite Liaison blog where you can learn more about the fires, but I will play this animation here and you'll see the hotspot and the smoke come out as well. So you can see this is in California, the fire hotspot really exploding after sunset there near Chico, California. And again, you can see the smoke there has a different color than the cloud cover here and the GeoColor imagery. So this is GeoColor combined with channels 5, 6, and 7, the fire temperature RGB, where you can really see some of the surface emission radiation and the intensity of the fire. And I believe this product can also be found on the Zero slider, which I will show in part 4. So in addition to those RGBs that I showed, there are derived products for a fire and hotspot provided from geostationary satellites, like the GOES fire detection and characterization level 2 products. Fire power, fire area, and fire temperature are provided by this product suite. There's a quick guide here. This is what it may look like in our operational workstations. You can actually pan over an area and see the fire area. the fire power and the fire temperature. So area there in meters squared, how large the fire is, the megawatts or firepower, and the actual temperature of the fire. And comparing the fire temperature, for example, with the fire temperature RGB, where we saw it saturates around 500 Kelvin, can be a good cross-check just to see the structure and nature. So this is all geostationary capability monitoring right now that I'm talking about, because I know there were questions about how that differs from polar orbiting, and I will get into some of that. So VIIRS active fire also does fire detection and fire radiative power. This is your polar orbiting satellite. So they will show where the fire is located, and with the finer spatial resolution can actually pick out on the firepower. So you'll see much finer dots here showing where the most intense areas of the fire are located, rather than just one coarse picture from geostationary satellites. VIIRS, when you have a pass, actually allows you to get more detailed information. So the next-gen fire system that I introduced, or NGFS, is a new experimental capability out of NOAA. This is a satellite-based fire detection system. And when combined with fire detection with National Weather Service products, like red flag warnings or fire weather warnings, can be used to inform decision makers. So you can see the physical properties of a fire that is burning. You can see the land cover type where the fire is located and the land fuel type, and how that fire is located with an urban-rural interface. So the population at risk, to inform emergency managers of decisions like evacuations. This is found on the SIMS Real Earth platform, and I will provide a link to the NGFS for a short exercise. But this is the Goes East fire detection, that level 2 product I showed, overlaid on GeoColor from SIMS. So for some pre-fire conditions, there are some important products to look at. One is Lightning Cast. This is a machine learning product being used to create predictive satellite detection of lightning. So a lot of these satellite products now, as in any other field, AI machine learning is being increasingly used to combine data sets to get a predictive nature of satellite imagery. So lightning cast is the probability that the GLM will observe lightning over the next hour. There is lightning cast available from SIMS for other sectors, like a Himawari sector for the Western Pacific, to see the probability of lightning. This is trained on 4 GOES ABI bands, 3 that are used in the day cloud phase distinction. So you can see here on the right, the day cloud phase distinction RGB I introduced in the last section is shown in the background. These lightning cast contours are probabilities lightning will occur in the next hour, 10, 25, 50, and 75%. And then the GLM flash extent density there with the blue polygons actually showing where lightning is occurring. So you can see here the time sets with the quick guide really show the advantages of lightning cast. Looks like probability started showing up around 1836 UTC in this example. Lightning occurred at 1911 UTC. So that's about 35 minutes of lead time for lightning. Really important for fire detection. Again, dry lightning, something that happens out west where there's not much precipitation and dry soils, can quickly ignite a fire. So in addition to this contour-based product, there are dashboards in the United States. If you have a significant location of interest, say an airport out west, there are dashboards for airport stadiums and even wildfires with parallax corrected data to show the probabilities of lightning through time and if lightning actually occurred. So this is again a new machine learning based product that can provide some lead time for one of those factors leading to fire ignition. I will get into some of the vegetation products here. So this is the GOES East GeoColor imagery from June 27th, 2023. So GeoColor imagery, the GOES ABI band doesn't actually have a true green band, but VIIRS does, as does the Mediasat satellite from EUMETSAT. So it's kind of a proxy green here, showing the vegetation where you'll get a true color from the polar orbiting satellites, but again, provide a human-like view of the Earth's surface. Really important for vegetation monitoring because you can see where there's browning of vegetation in a drought. Just a good situational awareness tool to pull up while you're investigating the environment. We also will get into soil moisture. This was a question that had been brought up if polar orbiting satellites can provide soil moisture information. Sensors like that of MODIS that can provide vegetation and NDVI are used in the Sport Land Information System percentiles product. This also uses the North American Land Data Assimilation System. This is produced by NASA Sport. It shows soil moisture percentiles on a given day. So mid-July of last year, for example, you can see out in the Pacific Northwest of the United States, those 0 to 10 centimeter soil moisture percentiles were below the second percentile, so very dry soils. And there are different layers, so 0 to 100 centimeter soil moisture percentile, just showing how wet or dry the soils are. So important from a fire detection perspective, also important if you're looking at burn scars in a flash flooding perspective. And again, this can be found right on the web. Burned area rapid interim severity risk maps. So this is the delta normalized burn ratio showing the severity of a burned area while a fire is ongoing before contamination. So this is meant to be a filler before the USGS Bear team in the United States can actually investigate a fire once it's contained to see the damage it did to the vegetation. These maps are provided by SIMS as well, again, a public-facing portal, preliminary, non-operational, but you can, as a GOES imagery satellite comes in, you can actually see with coarse resolution the DMBR of the fire, and the resolution will become better as other polar orbiting satellites pass a fire, such as VIIRS and then Sentinel and Landsat. NESDIS STAR also does produce some 1 kilometer NDVI weekly output from polar orbiting satellites on JPSS like VIIRS, and I do believe they do sectors outside of the United States. So if you are an international member, you should be able to see some NDVI profiles. Again, just a good situational awareness tool for vegetation monitoring, how green or brown the vegetation is, especially if you're suffering from drought in a given location. You can see weekly output at 1 kilometer shown here on the right. For example, this is early May in the state of Maryland. That is also an input to the fire risk product, also produced by NESDIS STAR. They also use other products from NESDIS STAR like the Thermal Condition Index and Vegetation Condition Index, which relies on VIIRS imagery to look at the health of the vegetation and fire risk, showing the condition potentially available to trigger a fire. If there's fire risk, there's above normal risk for fire ignition, or average risk, or if there's a desert or snow ice where fire is not as likely, that is also depicted. But again, similar output to what I showed on the last slide. Good situational awareness tool if you know fire weather is on the way. So I wanted to show an example from Scott Lindstrom from SIMS, the Cooperative Institute for Meteorological Satellite System Studies. This is the House Draw Fire in Wyoming from August of 2024. In this Real Earth platform from SIMS, we're looking at lightning cast there on the left, showing a 25% chance that the GLM will observe lightning in the next hour. We also see GLM is actually already observing lightning. So we see that there's lightning out here in Wyoming. Again, August in Wyoming, usually pretty dry. And when we see lightning, that could be an indicator that fire ignition could occur. We look about an hour and 5 minutes later, that's convection has moved off to the northeast. Lightning cast still predicting there could be further lightning strikes. And the NGFS, Next Gen Fire System, actually shows fire detection there. So an example of how lightning can ignite a fire, 1 hour later, fire was ignited there with the house straw fire in Wyoming. Talking about the day-night band and the VIIRS near constant contrast, which the day-night band's an input to. I know we had some questions how that can help with fire detection. 2023 and 2023 in August, Maui Island had some significant wildfires there on the western parts of the island. And we see city lights there, for example, with Honolulu, but also wildfires. You can see some of that light even, heading off the coast there in Hawaii. Those are actually wildfires. So you can see that with clear sky conditions. I have Bill Line from Nesda Star, an imagery scientist there, showing more imagery and the factors that led up to these devastating wildfires in Hawaii, but this is the Maui fire. The day fire RGB, again, I showed a lot of those RGBs that are popular, available in geostationary satellites, but also remember VIIRS has usually all of the same bands as geostationary satellites or even additional ones, and you can see if with a high resolution pass some of the fire imagery. So this is 9th of August 2023, and you can see the fire detection there. This is on Maui. We see really massive hotspots there, and west central Maui as well as northwestern Maui. You can actually see a smoke signature as well there with the kind of off purple color with the winds sending that smoke offshore. But another great example from Bill Line's Satellite Liaison blog. And I do have a video here. This is the Goes West fire temperature RGB. So this is a geostationary view of the fires. So you're going to have imagery at a much higher temporal frequency than those polar orbiting satellites, and you can see the wildfires evolve and grow overnight. This is from Sierra Slider. Again, once those, you can see those hot spots, especially on northwestern Maui, as the sunsets grow and evolve there for those devastating wildfires. And I'll play that animation one more time. Oh, sorry. All right. And I just want to grab a link to the Next Gen Fire System really quick. Again, if you have any questions, feel free to put them into the Q&A. We're going to be moving into the knowledge checks, and then I will also be answering some question and answers. So let me pull up a link real quick, but feel free to please keep writing any commentary in the chats and Q&As in the Q&A tab. So I just put a link in the chat to everyone for the Next Gen Fire System, and we will be doing a knowledge check. What is the Next Generation Fire System? This new capability for monitoring fires, if you could provide just a quick written response and see if you can access the page and provide a little bit of information about it in the chat, similar like we did for the knowledge check in the last section. In the meantime, I will be looking at the Q&A section and answering any questions coming in there. If you were able to get to that Next Gen Fire System page and read Welcome to the Next Generation Fire System website, if you can just answer the knowledge chat in the knowledge check in the chat and provide it just a one sentence, few word overview of what is the Next Generation Fire System. I see some good answers coming in now. Thanks, Megan, for putting the new caps quick guide into the chat and the new cap soundings. So that is the polar orbiting satellites with the sounders there that can get the vertical temperature and moisture information. I'll allow about 1 more minute for an answer to this knowledge check here. Alrighty, and yes, it does look like we're getting a lot of answers there. With the general overview, I'm glad everyone was able to access the page that answered satellite-based fire detection system using a variety of different products from the National Weather Service and satellite products to provide more insight on wildfire conditions for fires. So yes, great answers there. And moving on to the next slide, I will provide another link. And if you can just tell me how many active alerts are there over the past 3 hours for fire detection. Again, just getting you familiar with the platform. And I highly suggest that those explore this on their own time if you'd like to see more of those other parameters I mentioned, like the urban rural interface and the land type condition that you can see when you actually click on a fire. So I will provide a link now in the chat to the alert dashboard. And if you can tell me in the knowledge check, how many active alerts are there over the past 3 hours? That should be the default time constraint there. You shouldn't have to change anything, but if you could provide a count of how many active fire alerts there are in the last 3 hours, just to make sure everything's working on your own. All right, and I'll leave about 1 more minute there. I'm seeing a lot of responses. Yeah, I think unfortunately it is a busy fire day so far, so there's a lot of alerts. The other day it was easier to manually count. I'm not sure if there's a way to get the total count easily, but around 40, 43 was correct. So it seems like most of you were seeing the right thing there. Some great responses. And I have one more knowledge check here before we move into, I'll look into the Q&A from this section, but a knowledge check. What ABI band is the best for detecting fires? All right, a lot of responses came in. Yes, band 7, the shortwave infrared band, is generally the best for fire detection, even those that aren't as hot. But I did like the point that when saturated, the other ones, band 6 and 5, are important for fire detection as well. So great responses there. And we are at the end of section 3, so now I'm going to get into some of the questions that have come in. Is there a way to distinguish prescribed fires from wildfires other than ground truth? I'm not sure if there is a capability. I definitely think the follow-up sections could provide from more insight. But I know that in the NGFS or Next Gen Fire System, there will be kind of on that ranking scale. One is tells you if it's a known thermal anomaly source. In satellite imagery, that can tell you, there is a thermal anomaly detected, but it's likely not a fire or it's a known source. So there is that capability from the NGFS. The machine learning lightning cast product. Yes, I did introduce that. Is that available for South America? And that does go down to Northern South America. If you're interested in getting a sector added, I can always work with the developer and see if that's possible from the Sims Real Earth platform. But there are various sectors around the globe. I know Northern South America, and when we get into the satellite resources section next, I can provide an overview of that. Yes, John Centeno did also put into the chat that I did not bring up, but I will in the next section. CSPP Geo package for lightning cast is available. You can set up a real-time feed or look back at archived cases for lightning casts, and I do believe that can get you the South American coverage as well. So I'll show those resources. John put them into the chat in the next section. Can geosatellites help with some of the false positive hotspots that come from the same location? If so, how? I think that gets really well into the answer of the known sources or not. With the NGFS known thermal sources where you see these false positives showing up, those are actually being filtered in the NGFS. So I would go back to that answer I had for a previous question. And I can show you what I'm talking about there. So in the alerts dashboard, for example, you'll see the automated alert ranking rank 5. Detected thermal anomaly is co-located with a known persistent thermal anomaly source. So that's one example for the NGFS for US users if a detected thermal anomaly is co-located with a known persistent thermal anomaly source. Are there any fuel moisture products from either Geo or Leo? I know there's some of those fire risk products that might go into fire fuel moisture, but water vapor fluxes from large wildfires, I'm not sure off the top of my head. But again, I'd say maybe in those follow-up questions, some of our other fire experts might have some better answers. One question, is the soil moisture data available for the Indian region also for 0 to 10 centimeter level at very high resolution, temporal and spatial? I'm guessing you were referring to the NASA Sport soil moisture product. I can put a link in the chat for you to explore. I'm not sure off the top of my head how global that goes, but I will put that in the chat. It does appear to be mostly a CONUS-based tool. There is an experimental GoSpheres fuel moisture product from NCAR. Jarrell Torres shared in the chat. Thank you, Jarrell. So you can click on that link to find out more information. What tools are used for mapping how wind changes like the Santa Ana winds? So I'm not sure if there are tools for seeing how winds impact wildfires. Definitely a lot of case studies like those on the satellite liaison blog that show, how the winds move the smoke in the fire. There's also derived motion winds to look at lower level winds to show how that's moving with the smoke. So I would refer to that. Always Santa Ana winds are going into, some of the fire weather warnings and things like that for the pre-existing conditions that alert, conditions are favorable for fire ignition. So I would, I know derived motion winds may be available. There's also other optical tracking imagery tools being developed like Octane that I didn't produce here that can look at, the cloud topper smoke speed and things like that. Is anything known about the capabilities of the fire instruments on the next generation of GeoXO geostationary satellites? So yes, I know the 3.9 micron band, that band 7 that mostly everyone got right in the chat for fire detection is expected to go from 2 kilometers to 1 kilometer at this time. Know that, the requirements are still underdeveloped, but there is definitely an emphasis on improving that fire detection capability. So we should see an improvement in spatial resolution there, which is really important, as you're waiting for those Beers overpasses. So I will type that answer into the chat. Alrighty, and I'll wait a couple more minutes for any questions before we can break into one more 10-minute break, and then we'll have a good satellite resources section 4, and a longer Q&A there to follow before we wrap up for the day. And Megan did put a lot of great resources there in the chat, the Next Gen Fire System, NewCap's Quick Guide, which was shared, the CSPP Geo Lightning Cast, and So if you want to view lightning cast in South America, and the fuel moisture product and sport viewer. Alrighty. Right when I said, does the NGFS cover the whole world or just the USA? I think with the Weather Service input, this is a US-based product right now, but I know a lot of our international users will be looking forward to Section 4, which is about to get overway with satellite resources, and I will be showing a lot of global imagery products and things like that, even based for fire detection. So look forward to Section 4. If there's no other questions, I think we're getting caught up on the agenda. Maybe if we want to take one more 10-minute break to 11:05 or 15:05 UTC, and then we can move on to Section 4, which will be a lot of me showing where these resources are located, so you can browse on your own and not just wait for the presentation. So if there's nothing else, I say we take a 10-minute break to 15:05 UTC. Feel free to keep coordinating in the chat or add any questions to the Q&A if you have anything. So you can browse all of these resources on your own. These are all going to be web-based links, and then we will have a longer Q&A discussion available if there are questions. So I did want to address a question that occurred during the break. Does NGFS maintain history of the event pixel detection when it gets updated from ranks 4 to 3 to 2 to 1? I'm not sure if you can track that by fire in an easy-to-go manner. I know that there is an archive of the alert reports that you can look at for each fire based on calendar day. So I'm going to put that link into the answer there, and I can put it into the chat. This might be a slower way of doing it. I'm not sure if there's a way to do it more quickly, but that capability is there with some work. So I will share my screen and we will get into the satellite resources now. Part 4 of the short course. So the first resource I'm going to go over is the Sierra Slider. A couple quick notes before diving in is that this has an archive of imagery for over 2 weeks. So if you have a recent case study of an impactful weather event that you want to look into, this is a great resource. Also a great resource if you want polar orbiting imagery in addition to those geostationary satellites, and that does encompass Himawari and Meteosat on the geostationary side as well. Here's an example of output from Sierra Slider. You usually will see this Sierra Cooperative Institute for Research in the Atmosphere logo in the bottom right. This is geocolor imagery, for example, from mid-May this year when an atmospheric river impacted the eastern U.S. And the group energy density from the GLM, I really like the look from that, is available from Sierra Slider. So I can get into the link now. Again, should be linked to the presentation. This is the GOES 19 full disk view. The way Sierra Slider works is you can choose by satellite. So you can see a lot of different options here, mostly geostationary, but we do have JPSS polar orbiting satellites. So if I wanted to look toward the Western Pacific, I could click on Himawari. Sometimes a quick refresh of the button will help it load faster, but you can see the different sectors there. I'll go back to GOES East, which is GOES 19. Full disk view, so every 10 minutes you can change your sector. If you want to just look at the United States, CONUS sector, 5-minute imagery, that does go down into the Caribbean as well, or mesosector for 1-minute imagery. All of those capabilities are there. And you can see the variety of products available for the full disk. So you have your 16 bands, your level 2 products. Again, some of these are more experimental, so just beware there might not be a quick guide or operational support for all of these products. All of your RGBs are multispectral imagery and RGB composites. You usually see the source of where those were developed. A lot of these started out or in coordination with EUMETSAT and Meteosat, but you can see a lot of these RGBs that I did discuss in the presentation, like the fire temperature RGB, is available. So if you know where a fire is occurring, it's easy to use this RGB. You can zoom in and out. Again, sometimes I just do a refresh to help the load rate. But this is available, and you can go all the way down into South America as well for our international users there. I can see Meteosat 10 has a lot of different products as well. Here's the true color imagery. It does have this is still geocolor, but they have that for Meteosat. Let's see if we can get day fire. But there's a variety of different products here available. So I'll go back to GOES. Another thing to be aware of here is there are also polar orbiting satellite imagery. So the JPSS satellites here, we can look at the different bands here in multispectral imagery. So if I want to look at the fire temperature RGB from Veers, I can do that. Again, the times are going to be jumping because of when it's available as it passes the CONUS, and if it's dark, it's nighttime. But you can also, for these, increase the number of images if you want to see more daytime imagery. You can zoom into a location. Here's a fire hotspot, for example, that was viewable right from Veers. And you can see the high spatial resolution from the polar orbiting satellites and fire temperature RGB. So there's that. Some of those precipitable water products that we're talking about that microwave sounders are inputs to are also available on Cirrus Slider. You can see, again, the source and the length of the moisture plume. You can play the animations and see what's going on. That gets into a lot of the capabilities for satellites, sectors, and products here. Again, Northern Hemisphere for polar orbiting. Before I move on, you can view Southern Hemisphere as well. And if you want to zoom into a location like South America, you just will have to play with this rotate by n degrees to get it to a proper viewing angle. But that is available from polar orbiting satellites across the northern and southern hemisphere. Someone had asked about the CRIS imagery as well. That is available from the JPSS satellites. You'll just have to go down to the CRIS imagery. It has its own section, and we can view things like the AMS RGB that I showed in the presentation. A good thing about a lot of these products is that they have legends, and some of them will have info. Again, some of those underdeveloped, there might not be additional information currently available, but there are a lot of different products here. So the other thing I want to show is if we wanted to look at archived imagery and see what yesterday's weather was like during the afternoon across the full disk, I can do that. It's just setting a begin time and end time. You can see how far back it goes for the full disk. It's about a week. For CONUS, about 2 weeks, but you can see it automatically updated. So this is actually yesterday's weather that we're viewing. You are able to download images or animations or create your own animations from Cirrus Slider as well. So be patient while you start the download, but that is available. And there are other available features like feature following, where you can follow a thunderstorm if you want. All of those are available from the Cirrus Slider. So again, if you have any questions, you can put them in the chat and I'll try to answer. I think for this section, it might be better to put your questions in the chat as they come up, and then I can leave one resource and head to the other. So that's the Cirrus Slider. If you have any questions about Cirrus Slider, please put them in the Q&A section or the chat, and I can field them before moving on to our next resource. Jarrell did put the Cirrus Slider link in the presentation for everyone, and CRIS imagery is only available for the northern and southern hemisphere sectors. Jarrell is our JPSS satellite liaison expert there, so he's able to provide all of the CIRA and JPSS input. Thanks, Jarrell. And I did a very quick overview, so a lot of these questions you can always follow up after the presentation to me, but wanted to provide as much of an overview as I could with the short amount of time we have. Seems a bit slow to load. Recommend browser, memory, GPU, high-speed internet. Jarrell probably can put some notes into the chat there. But I use Chrome. It usually works okay. Again, a lot of the reloading, refreshing the page for me seems to work. And if You might not want to load a super long time frame with lots of images. I would start small and expand, but those are just some of my user experience input. All right, it seems like my response was adequate from Jarrell. So there's that. Feel free to keep putting questions into the Q&A. I'm going to move on to the next section here. All right. So that's the Sierra slider. There is the GOES imagery viewer. So this is just for the GOES East and West geostationary satellites from the United States, but this does provide imagery for the full disk down to South America with an archive of about 10 days. Just geostationary imagery, no polar orbiting imagery for this, but there are select RGBs, some of those I introduced, and derived motion winds, and the GLM flash extent density. Here's an example of what the output looks like on the right. You'll see a NOAA emblem in the bottom left. This is the geocolor imagery overlaid with derived motion winds at different layers. The red, for example, is from 100 to 400 millibars, so upper level derived motion winds. This is that same atmospheric river that impacted the eastern U.S. in mid-May, and you can see the transport of moisture there really well from the eastern Pacific, very fast winds up into the eastern U.S. So really good for tracking the motions in the atmosphere with the derived motion winds, and I will get into the GOES imagery viewer. So let's see, nothing in the chat. I will click on the link. And we'll go into the GOES imagery viewer. If my computer will let me. Seems like could be frozen. Okay. All right, I did, my PowerPoint did not like that, but I will just show you the GOES imagery viewer myself. So I'm still sharing my screen. It might be a problem with the actual website. It's not wanting to load for me. So we might come back to that one. But yes, the information, I think my PowerPoint is back. Still is accurate there that it's an archive of about 10 days with the GOES imagery only. But again, this does allow the South American sector to be viewed with the full disk imagery. So SIMS Real Earth is the next one. We'll see if this one pops up. Yep. So it must be just a GOES imagery viewer site right now. So this is from SIMS, another cooperative institute like Sierra. They have other products on here. Some quick notes about SIMS. They have an archive of about a week for most imagery. They have geostationary imagery and low Earth orbit imagery, operational and experimental imagery and products. Here, for example, here on the right, I'm showing from that same atmospheric river, the infrared imagery band 13 with GLM flash extent density shown there and the lightning cast contours. So this is the type of imagery that you can view from SIMS Real Earth. So here is the portal here, and you can do a quick search for products. If I wanted to search for lightning cast, I can do that, and they will populate here on the left. So if I want to look at GOES East CONUS full disk OCONUS, for example, I can pull that up, and you'll see the lightning cast contours pull up and a nice legend showing what the contours mean. But by themselves, they're not super useful. I might want some imagery shown there as well. So let's say if I want infrared, I can search that. and I can go down to the find what you want to look for. Goes East ABI full disk clean infrared. Pull that up. And you can see right now it looks like the lightning cast contours are covered up. You can actually pull and switch the order of the products as well. So again, you can see lightning cast does go down to Northern South America here. I'll show CSPP Geo next, which is a package that you can actually look and generate the imagery farther south. But you can see the product here. Looking at this tropical cyclone, for example, in the Eastern Pacific, I can look at the probabilities of lightning. I can also overlay GLM to see where lightning is actually occurring. So if I want to look at CONUS GLM flash extent density, I can add that there and see where the lightning is actually occurring as well. So there's products like lightning cast that are there. There's a variety of other products as well. I know some people were asking about flood mapping earlier in the presentation. So if I do flood, maybe it'll come up. For example, there's the Veers River Flood one-day composite. There's the ABI flood products. So if I want to look at River Flood one-day composite, I can zoom out. I see from Veers, it's giving me a global look from these polar orbiting satellites. Click on the information. You can see more information about this product, kind of like you could with Sierra Slider. All Veers daylight imagery over the past day, and I can zoom into different areas. For example, in Northern Africa here, and see the products again. If you want to see the legend, you can click on this information button and see more, or view in the product catalog to look at even more information about the product. So nice interaction there if you want to learn more about the product, but flood mapping is available here. So if I wanted to, I have GeoColor pulled up now, goes west from today. If I wanted to go back in time, you can see ending. You would change that end date, and I could go back to the 11th of June, apply changes, and you can see the timestamp at the top changes back to June 11th. Can animate just like you could on Sierra Slider as well. And there is this share feature here where you can download a movie, an animation, or an image. Again, it allows some time for it to load and buffer. Or if you just want to share the link with someone else in the community, you can just copy this link here, and it should take you directly to what you were viewing. So that's another nice aspect about Sinton's Real Earth. So I will take a pause now as well, like I did with Sierra Slider, and see if there's any commentary in the chats or questions in the Q&A before moving into the next section. So if you have any questions so far about any of those resources, please let me know. I will try to do the GOES imagery viewer again. So yes.
I also tried and wasn't able to get to the website, so.
Just must be down. That one I would say is a little more straightforward than the Real Earth or Sierra Slider in the terms of there's not, as many experimental products or animation or download features. So luckily that one is a little easier to learn than some of these other ones that actually have even more resources. So yes, slides and recordings will be available at the Satmoc link above. Zoom recordings, all survey links will be posted on the CSU Sierra website. It will take a day or two. Thanks, Megan, for that context. So if you have any questions, please put them in the Q&A before I move forward. Alrighty, I will jump into our next resource here. So this is what John Centineo was mentioning in the chat, the Community Satellite Processing Package, or CSPP. With some basic Linux scripting, after installing this package, you can actually download and view imagery in real time or for archived cases. So this does provide JPSS and GEO versions. So those polar orbiting and GOES imagery satellites. I think there might be some other geostationary satellites as well. But serving the direct broadcast community, but can also create visuals from archived data. So here on the right, for example, I looked back at this case study from October of 2021, looking at lightning cast imagery output for this thunderstorm complex that ended up impacting Barbados with some pretty impactful weather there. You can see the legend here in this output with the imagery. What's nice with this package is that all of that was created just with a simple command line script. So if you do have that experience, or if you have any questions installing, please reach out. But a lot of minimal effort there to make everything look right, which is very nice. So for the archived imagery, you can use, let me actually go to the package page first, CSPP Geo, for example. This is the home page. It'll tell you a bunch of different information. Looks like Himawari is available as well, and the different packages available for download and what they produced. For example, the Gridded GLM software package can create Gridded GLM output or GLM tiles, and what's available there. The download page, you'll need to create an account. It's free, but then you can actually download the package. There'll be a huge booklet on directions for installation, some of what you can and cannot do. So definitely recommend looking at some of the download and documentation. But this is a great resource for those for needing direct broadcast, supplement, or looking at archived cases is what I really like to use it for myself. So that is the CSPP Geo. You can use Amazon Web Services to download archived GEO data as an input to this package. If you didn't know, this is GOES 16, so we're on GOES 19 now for GOES East. But Amazon Web Services, AWS, does provide an archive of geostationary imagery. So if I wanted to look at the full disk imagery, you can see that the archive goes back multiple years. So if I wanted to look at an impactful case from 2018, I could do that. Once you get to there, it's listed by the day of the year. So you'll see it goes up to 365 days. So you'll have to see what day of the year, if it was October 11th, for example, that you really wanted to look at an impactful event. Go there to the hour, and you'll see each band for the full disk, for example, should have about 6 output files per band for the 10-minute imagery for that hour. There are scripts, and if you want to reach out to me following this with any questions about how to view this NetCDF imagery as well outside of CSPP Geo, I'm happy to help. But this is a great resource for looking back multiple years and viewing satellite imagery. I did want to reference a lot of these acronyms to the user are quite unclear what they mean. Luckily, there is a GOES bucket acronyms page where you can view what each of these means. So I did link this in the presentation. For example, advanced baseline imager data for the full disk is this ABI L1B RAD-F. So if you're looking for South American imagery, you'd want to download this product here. But there's a lot of Python, Jupyter notebooks, and Google Collaboratory notebooks, in addition to CSPP Geo, that you can visualize a lot of this archived imagery. So please reach out following this if you have any questions. I did also want to introduce CSPP Geosphere, another imagery viewing tool. What's nice about this one is that you can actually view here GeoColor and nighttime microphysics RGB. That's a popular RGB that I did mention. And you can You see the lat long readout. Can zoom in. This does, again, serve South America as well. And you can change the coverage or the satellite. Just goes east or goes west here. There are layers as well. You can look at single band imagery. You can look at some derived products from GOES, like land surface temperature, and add some different resources. So not as much available from this website, but I did just want to share another resource if you want something to just load really fast and get some situational awareness. This will be included after the presentation as well. This does have a share URL and download imagery or movie as well, similar to Sierra Slider or Sims Real Earth. All right, I will pause if there's any questions about CSPP or downloading archived imagery. Please let me know, but I will pause here for now. Megan put some of the landing page and Geosphere links into the chat. If you have any questions, you can put them in the Q&A. Again, I know I'm throwing a lot of the resources at you, so feel free to follow up after the presentation as well. Alrighty, and we will be moving on to the next resource here in a minute, so there's still more coming your way. Going to get into some of the training resources now. This one is developed by myself and Bill Line, an imagery scientist at NOAA, NESDA STAR, highlighting recent weather events and experimental satellite products. Also found on the University of Maryland Earth System Center Interdisciplinary Center, or ESSEC Satellite Observations website. But in this blog, if you're interested in seeing the National Weather Service forecasts and products being issued and some of the experimental satellite capabilities, as well as what's operational being used, this is a great resource. So you can click on the link here, and you can see, for example, a blog that I posted recapping a forecast for a recent weather event, some of the imagery used to see the evolution of the forecast. So you'll see a mix of satellite products and animations, as well as some overlays that our forecasters are using to actually depict the weather, and some forecast products brought out there. So there's a really long archive of blogs here going back, all the way to 2012 now. So about 13 years of content. You also have the ability to leave a comment. So if you'd like to interact on this forum, it's not the WhatsApp, but it is another scientific sharing forum here with the Satellite Liaison blog. So now just a couple more web links to get into of some other resources. I know I introduced scatterometer winds, ocean surface vector winds. NESDA STAR does provide this, and this does provide a global view of ocean surface winds and altimeters. So really useful for tropical cyclone tracking and things like that in waters, not just around the United States. You can see here on the left, they have the scatterometers. You also have altimeters to show wave heights. And it's interactive. I can click on an area of interest. So if I'm looking, here off the coast of the United Kingdom or Ireland, I can click there, zoom in. It will show me the ocean surface winds and the time, 1521 UTC. So very recent ascending pass. That's when it was produced, but you can see at the bottom actually the time, so 21 UTC. Ocean surface winds, a nice legend there to understand what the wind speeds are, really useful for monitoring cyclones over the water. Altimeters as well, global wave height observations. I can click on here, see the wave heights. These are in feet, as it says here at the bottom, so just be mindful of that.
We're still seeing the PowerPoint.
My
So
bad.
we're still seeing the liaison blog slide.
Yeah, no bad. My bad.
No worries.
Let me reshare. I think we should be good now.
Yeah.
Okay. So yeah, here I was just what I'm showing with the scatterometers here on the left. You can click on the different resources for ocean surface winds. Again, it's interactive. You can zoom in and see the winds with the legend. So if you have an area of interest, again, I was going off the coast of UK or Ireland, going there, you can see the output there. Altimeters are also available. Wave height observations are in feet. Like I said, the times here will be on the rate of the pass in UTC, and the source is the color of the times. So Sentinel 3A is this brown color, and you can see those observations there. So that is available online. Updates pretty routinely every day. So I did want to share that as well. Synthetic aperture radar. I know this was something I talked about, especially there were questions if there are any active microwave sensors. This is one. There's automatic SAR tasking for global tropical cyclones. So these polar orbiting satellites are tasked automatically based on Hurricane Center track forecasts to look at tropical cyclones. We'll see if that loads. I think some of these NESDIS sites might be having a problem right now, so I might just have to share after the presentation when this is shared. Yeah, I think it's the same issue that they might be having with the GOES imagery viewer, where we might not be able to see that. Yeah, let me pull up the presentation then and just talk about the slide a little bit for you all. So this should work again soon, but access to Radar Constellation Mission, RadarSat 2, and Sentinel SAR wind passes. Again, saw that example from the right earlier. There's also normalized radar cross-section, so the raw imagery data, you can see ice cover and things like that on this page as well. And I can add another link where you can see that. But again, let me know if you have any questions. Sorry that's down today. But that is another resource that's operational. New caps, we'll see if this NESDIS resource works. Layer and gridded new caps output across the globe. So this is the instability parameter from those polar orbiting microwave and infrared sounders. CAPE is a gridded output field, for example. So if we're looking at what the instability was, leading up to a severe weather day or something like that, you could see some of this information. See high CAPE, for example, there in Africa, up to 4,000 joules per kilogram. Just an example of what's available. This is from OSPO. This one's working. You can view by satellite resource. NOAA 20 or NOAA 21 are operational JPSS polar orbiting satellites. So you can look at temperature at the levels. This is the 1,014 millibars, so the surface level. I can look at some of those stability parameters. So CAPE, you can go back in time. If I wanted to look at June 3rd, what was the CAPE in the morning? So the thing here is they don't give, I don't think they give an interaction to see the exact time of the pass, but that is available with an archive. If there was an impactful weather event, it looks like it's at least about a month long there. So that is available for new caps from NESDIS as well. All righty. And I'll try one more time to see if that GOES imagery viewer is working for us before we move into the Q&A. Alrighty, looks like we're stuck there. So these are just some conclusions to wrap up the presentation. In general, GEO and LEO, or polar orbiting architecture, allow for a variety of observations and data for environmental monitoring, including vegetation and wildfire, as well as numerical weather prediction. And AI and machine learning for products like LightningCast are really allowing the combination of observations to create predictions using satellite going forward. Vegetation and fire monitoring are key capabilities that will set us up nicely for the rest of the sections of the short course later this week and next week. And there are a variety of resources to download and interrogate the archive data as well as real-time data. So if you have any questions, you can reach out to me there at csmith70@umd.edu or christopher.l.smith@noaa.gov. So I can also answer questions now. We have about 30 minutes extra built in for just Q&A and live discussion. Or if you have any commentary in the chats, please keep that going. But that does conclude the content of the presentation. Sorry, a couple of those links were broken here today. But I'm happy to answer any questions now.